Hello everybody and welcome. Today we'll be learning about ASGI. So if you're here, you've probably ever used a framework like FastAPI or Starlette, and chances are you may have struggled understanding how it works under the hood, and you'll be using some common standard approach like app.get, then you put a router in there, but you don't understand exactly how it's working under the hood. So the aim today is to understand how it works under the hood by cloning a mini framework of how FastAPI or Starlette works under the hood, and that way we can ultimately understand how ASGI works and how frameworks like FastAPI and Starlette use ASGI via Uvicorn. So by the start, what is ASGI? ASGI is asynchronous server gateway interface. That means we want an interface of our server that can be called asynchronously, and that's what makes FastAPI fast, because its interfaces can be called asynchronously. By asynchronously, it means that it can be called to do something, and even if that previous call is not complete, you can make another call, because that previous call will be put on pause so it can execute in the background, so the server is available to receive another calls. It's different from something, let's say, like Django. Django also has ASGI, but by default it uses WSGI unless you manually set it to ASGI, but by default it uses WSGI. So that means its interfaces, when called upon and something takes a long time to complete, the requests will be put in a synchronous way, more like they are waiting for one another to complete. Now, what exactly is ASGI? We can go to the documentation. This is basically a protocol or a standard that is supposed to be used, and frameworks like Uvicorn use it. So ASGI simply means is a structured single asynchronous callable. Basically, you create a function. It all ultimately boils down to a function that encompasses the whole application. A function that can be called asynchronously, which means it's a function that can be called multiple times if the previous call has something going on that is not complete. By a process that is not complete, you can think of it from multiple endpoints. Actually, you can think of it as IO bound. IO bound are those calls that use input output interface. Let's say like database, like initiating a database, or making a call to a database. That's a call that can take a long time depending on the query you sent to the database. So if that particular call is taking a long time, you don't want the endpoint to be stopped waiting for the previous call to complete so that it can receive another call. You want to send that call out automatically to the background and be able to receive another call, and when that previous call is complete, it can come back and continue its flow, its loop, or whatever. Or there are CPU bounds. Now, these frameworks, we'll talk about CPU bound later, but so the ultimate goal was to create a framework that imitates how FastAPI or Starlette works by creating an asynchronous server gateway. So what we're going to do is a classic way of dealing with Python by first creating our virtual environment, Python 3 virtual environment. Then we're going to use that virtual environment, and in this virtual environment we will pip install Uvicorn standard. basically we are going to use Uvicorn. Uvicorn is the server that will be listening to the requests and handling everything. So I've installed it. You can see it has installed a lot of things that comes with it. It was cached by the way because I was doing some things with it before. So we install Uvicorn. Think of Uvicorn like Node.js for those who develop in JavaScript. So Uvicorn will be the one handling the requests in an asynchronous manner. What we need is a wrapper on top of it that can enable developers to use Uvicorn. So think of FastAPI like a wrapper to Uvicorn, or Starlette like a wrapper to Uvicorn. So what we're developing right now is a project that will be used by another developer. It's a good way to think of it if you're a developer your own, because ultimately you understand how they work under the hood now. So after installing that, I'll create just a simple file over here called main.py so that we can put all those things we learned into practice and understand how they work. So in here, now you can see it installed typing, so we will import typing. Typing, it's not really necessary, but it makes the code easily readable by type hinting. Ultimately, when the code is, I don't know, compiled or whatever, down there, it doesn't use, it's not static type like Java, but you can put type hinting so that your code is easily understandable. So we're going to, from typing, we're going to import callable. A callable is how to say something is a function. You can see here it said we need an asynchronous callable. So when we make a asynchronous callable, we will say this is a callable, and we need a dictionary from it. We need any means just any other type if we don't know it beforehand, and we need a list. We need a tuple too. So we won't use almost all of those, most of those at the same time, but let's just put them out there. So we'll create our synchronously callable function, async def application. Now I'll put these arguments exactly how they are in here, then I will explain them later. You can see even in their documentation they don't have type hinting because it's not really necessary, but it's just good to have it if you want to read your code and understand it. So you're going to put scope, and you put them exactly how they are, because if you don't, they tend to complain. So we have an application that receives scope, receive and send. I'll explain those, but let's just get it started first before we start explaining anything. So right now here we have a function called app. It's a function that's called app that has async capabilities, though they are not used right now. I will show you how to use the sync capabilities later. We have those, and the function just says pass. So right now we use Uvicorn to go to the main file, find a callable. A callable is any function, method, or we'll see later how to make a class callable or a class instance callable by using the call function. So we're telling Uvicorn go to the main file, main.py file, find a function called app and call it. And we're putting reload so that whenever we make changes, Uvicorn will be watching the file, and when we make changes to it, it will reload the server or the program, whatever. In production, you won't do that. And when we do that, you can see our server is on. And even if I visit the browser over here and refresh, you can see internal server error because we haven't handled anything right now. The callable is there, but it just does completely nothing. So what is scope, what is receive, and what is send? Scope is basically a dictionary that Uvicorn sends whenever there's a connection, and that dictionary describes what type of connection that is, because asynchronous servers handle many types of connections compared to WSGI. I don't remember the long form of WSGI. So it can handle a particular type of connection. I will show you later. It's called lifespan. It can handle HTTP. It can handle WebSockets. We'll show all of those. So it's a dictionary. Basically, a dictionary needs a string. So the first thing is a string, and what follows here is anything, because I will show you how that is. And when Uvicorn sends the scope, it sends a receive function that enables your application to receive a connection or receive data, whatever. So this is a callable that they will send you. You don't create it, they'll send you and you'll just use it. And they will send you a send function also. It's a callable. You use this to send response back. Now, our function ultimately returns nothing. So just say none at the meantime. At the meantime, we'll just say none. Now, I'll just print scope here so you see what's going on. And before I save that, let me just stop this. Then I'll start it again. I'll save this and start it again. Now, the moment I started it, we printed the scope, and you can see the moment the server starts, there is something that was sent to this this interface or this function, and that is the scope. All these were sent to, but we just reviewed the scope. You can put them to if you want to see them. It just say it's a callable, or it's just a function basically, but it's sent ready for you to use. You can see, so it's a method sent. There's also another method sent by Uvicorn itself. So the scope defines the type of connection. Now lifespan, the lifespan scope is special. It's a way that your application tells the server whether it has started or it has ended. It's a way of Uvicorn telling your application, hey, the server has started, you can do something, or the server is ending, so if you have to do something like whatever. So that is the scope. This lifespan scope is a communication between your application and Uvicorn, not the client. It doesn't involve the client. But there's other scope types like HTTP, which is your application and your client. WebSocket also your application and your client. So let's try and deal with HTTP so you can see. I'll just say here, I'm putting a fail fast mechanism. So if we receive something that is not HTTP, it can fail fast. So I'll just say if the scope is equal to, if the scope type, whenever the scope comes, it comes with a special key called type, which you can use to identify the type of connection that your application has received. So if the type is HTTP, then the program will follow whatever is down here. If it's not, it won't follow whatever is down here. It's like an if statement, but it's a developer friendly fail fast kind of if statement. You can read on assert on your own. So if I receive HTTP connection, what should I do? If I receive HTTP connections, I will print the scope again so you can see it. So now, because we haven't handled anything, I'll send a request again, and when I come back here, you will see we had lifespan when the server is starting or reloading. But soon as I send the request via my browser, you can see here the request that was sent. You can see it right here. No, I had these two, so it printed them, and we don't need them anymore. Okay, let's refresh again. Okay, so here it is. It started. You can see it started with the lifespan, the way that Uvicorn told our file that the server is started or is completely on, so you can do anything. Then when we went to the browser and made a call to this endpoint right here where our server was available, it says, when the server starts, it says somewhere. Oh, let me stop it so that you can see it clear. The Uvicorn app reload, you can see that the server is available at this port. Uvicorn is listening on this port at localhost on port 8000. So when we go back here and reload again, we're expecting an internal server error because basically our function is doing nothing as of yet. Printing is doing nothing. We're not handling the way we send responses, nor the way we receive data from our clients. So what was sent was another dictionary. So remember, scope is a dictionary. Every time, remember, scope is a dictionary. And the type this time around is HTTP. It says the ASGI version, HTTP version, the server where it's listening to, the client, and everything else. Headers, everything is in here. So depending on what you need with them, you will find those in here. But we'll use some of them to explain some key concepts later. So that way, we already know how to handle the scopes. So if it's HTTP, let's try and send some data back. So to be able to send some data back, we need a few things. We need the status code. Status code enables you to send your response back by defining, if it's 200, maybe somebody has made a correct has hit a correct path in the particular resource. You do have it, so you can send it back. So we just deal with status code 200. And we need headers to be associated with our response. And headers is a list of tuples. Understand this? It's a list of tuples, and these particular tuples have bytes in them, a byte data type in them, which is content type. If you've worked with any APIs, these are common, so I want to explain them. And we'll say we are sending things back as text plain. I think right here it's supposed to be something like this. If it wanted to complain, and I will come back and change it. So we have set up our status code, we've set up our headers. What else do we need? Okay, now we can send it back. Now here you'll notice I'm using await send. This is where our function really becomes asynchronous, and I will explain what await means if you've never used asynchronous programming before. So what we are sending back is also a dictionary that has a mandatory key called type. What are you sending back? So I'm sending back, because I've received an HTTP request, I'm sending back HTTP response dot start type. This is sending HTTP dot response. Then I'll send a status so that we know what to do with this particular response. It can be for it can be, you can read the status codes of HTTP on your own. And we'll also send the headers. We already have them. Now the way we send back requests is two-way, in a way that you send first the headers on their own, then you send the body later. And we forgot to put the body, so we just put it over here. It's also a byte type. hello, this is our Uvicorn server. So here we'll switch this with body and use the body we created, and this will switch it up with more body to tell it if there is more chunks of body coming back. And this is a boolean. So right now we have a server going on. This here is status code. Any other errors, you can ignore these because it's just a warning, and it's because the IDE hasn't seen my venv, and I'm using Z, not VS Code. So if I come back here and refresh, I still get an internal server error because got HTTP start. Oh, I copy pasted, the troubles of copy pasting. So when you're sending the body, after sending a HTTP response start, you're supposed to send the body after it. So I didn't send the body, I sent it because I copy pasted. So right now when we refresh, you can see, hello, this is our Uvicorn server. So what happens here is let me start it again so you can understand it exactly what's going on. So we have Uvicorn main app reload. We're telling Uvicorn to go to the main file to find a asynchronously callable function called app. We started the reload, you already understand it. So okay, that's a mistake. So we start it and our server is on and listening. Okay, by default the first thing it does is Uvicorn itself sends us a lifespan signal that the server has started. You can see when I printed scope, the first thing we were sent is a lifespan signal, which we did not use. Then after that, we did set up our HTTP environment to receive HTTP, so that whenever something comes that is not HTTP, that's why when this assert checks if the call coming is not HTTP, won't proceed doing anything down here. So when the call was lifespan, none of these were executed because it failed fast right here. Now, when the HTTP calls come, that's another invocation of this function right here. It's called again. When it's called again, the flow, it comes in here, checks the scope, finds its HTTP, it continues down here. When it continues down here, it finds something called await send. This await send basically says, hey, you can send this response back, but if it takes a long time to go back to the client to complete, basically, we can pause this full invocation. Remember, whenever you make HTTP request, this function gets called again. Okay, so we're just telling Uvicorn, hey, you can go to the main, you can call this. Whenever you get a request, go to main, make a call. Go to main, make a call. Make a call to application. So whenever you get a HTTP request or a WebSocket request, it comes here, it gets called, but we are sending it with await, which means if this particular step of sending back this request takes a long time, we can pause and receive another HTTP request. Now, being paused doesn't mean that that previous call is not going on again. It's still going on, but in the background from the event loop. Okay, so when it's still going on in the background in the event loop, when it's complete, it hands back the control back to the event loop, and it can continue to this another call, which also behaves the same way. If sending this particular part of responses, for example, this taking a long time is very difficult because we're just sending back a response start. But in this body part, assume if the body was maybe we're sending back a file, it can take a long time. So if it takes a long time, we don't want our server to be waiting or to hold up the queue for other requests. The fact that this function is async and this part of sending request, which is this callable, we have said it can await, means it can hand over the control back to Uvicorn to be able to call the app again, that's what we call the event loop. So it hands over back the control and it continues in the background, completing that process of sending back the response. And when it completes, it can come back and continue with its own routine, which it was doing. So that's the aim. So basically what an async function is a function that instead of calling it directly, whenever it's called, it returns a coroutine. A coroutine, you can dive deep on your own, but a coroutine is something that can be done separately and allow the function to be called again. If you don't use this and use await, it will fail. And if you use async without this, it's basically a function that can be asynchronously callable, but is not, because there are no point where you've sent something to the background and the event loop can be free to do something else again. So these two should be a match for a function to be asynchronously callable. Okay, so what else? So the way we did it right now is we did it in the main file so that everybody can get a complete picture. But right now we haven't created it for the developer. Basically, we've created something that as a developer himself you can fully do something over here. You can create a full function over here, but it will be cumbersome. It will be very complex. It will be very difficult. That's not good. So the main idea is to create a framework that does most of these things, and the developer can only worry about handling routes. That's why when you use FastAPI, you do something like app.get, let's say, a particular route, then that's a decorator. Then you come down here and say something like, let's say, async def hello world. This is supposed to be a string, by the way, before I forget. Async def hello world, and you can do whatever down here. Now, what this does is just creates a function that can be asynchronously callable, and we'll get to the point where you can understand exactly what's going on when you write a function like this in FastAPI or Starlette. So let's create a folder, call it MiniAPI. In MiniAPI, let's create a file, call it init.py. This enables our folder to be regarded to as a module, or as a package, I meant. And we are going to create another file called app.py. And we're going to take all of these codes. Let's just stop this server first. We're going to take all of these codes and move them to our app. Oh, I did not. Okay, cut, paste. Okay, so this time around we have a function. Now we don't want it to be a function, because when we deal with it as a function, there are things we want to store that we cannot store in a function directly. We want to make it a class, but make sure the instance of that particular class is callable. So how do we do that? We create a class called MiniAPI, and in here, let's just take all these let's just take all these and make them part of the class. And instead of creating an app function, we're going to create a call function. And the first parameter, as you all know, is supposed to be self, which is the instance of the function, or the instance of the class itself. So by doing this, we have room to create the initializer and pass anything in it and something like that. That means we can store things in this class, and at the end of the day, still the instance of this class can be callable via this particular function over here. So by the way, let's put those type hints so that it's just understandable. So we said this is supposed to be a list. A list of what? It's supposed to be a list of tuples. A list of tuples. And what do those particular tuples hold? They hold bytes, 2 bytes to be specific. They hold 2 bytes. Those are the headers. And I don't think there is anything else. I wanted to label this because it's easier that way. I'll just delete these. Let's make the code cleaner. We don't need to print the scope anymore. We can just delete it also. Now we are going to init, and we are going to say from app, from .app import MiniAPI. Then when you go to main API, now this is where the developer is using this particular package, MiniAPI package. In this, they can just say from MiniAPI import MiniAPI. Now this is enabled by this init function over here. I mean, with this init file, importing it over here. Without that, we were supposed to write something like from MiniAPI .app. Okay, so we have to know the particular file where that particular class is. But with init, you make sure whenever somebody imports from MiniAPI, those particular functions or classes that need to be really available, you place them over here. If somebody doesn't necessarily have to go to a particular file to get them. Then we are going to initiate our app here using MiniAPI, and we're going to run it. Hopefully nothing happens. And Uvicorn main app. We won't put reload right now. Okay, cannot import name MiniAPI from unknown location. Oh, the init file has an error in its name. I didn't see it. So it's supposed to be init file. So int, not int, init. Do that again, and now it starts. You can go back, and everything works just as fine. You can put reload just to see it in action if you want to, and we can change the message. This is message 2, and when you save it and reload it, you get this is message 2 sent back to the server as text/plain. Now all is well, but we've only so far dealt with one type of scope, which is HTTP. We saw lifespan as it was being sent by the server. Soon as our server started up, it was being sent by Uvicorn, but we haven't particularly dealt with it. So what is lifespan really? I think when we deal with lifespan, you can really appreciate their weight and their sync. You can get to fully understand the flow from that perspective. So let's say if let's do an if statement of checking whether the lifespan or whether the scope came with a type that is lifespan. Now, lifespan is I can say lifespan is our event loop. So long as a server is on, it's in its lifespan. Basically, that's self-explanatory. So if I'm alive right now, I'm in my lifespan. I don't know when I'll end. I knew when I started. So same applies to the server. So if it starts, it's in its lifespan. Now, you may want something to do when it's starting up. Okay, so when it's on, so long as it's on, you can deal with it as a you can deal with it as a you can deal with it as an infinite loop. So you can say something like while true, okay, while true. Okay, I hate it when things down here appear as errors when they're not, so I'll just comment them for a while and I'll uncomment them when we're done with them. Let's say while true, actually if the scope type is lifespan, I'm finding a better way to explain it. Just give me a minute. Give me a minute. Okay, let's just put pass over here. Oh, the explanation I needed in the documentation over here. So it's this over here. In its simplest form, an application can be written as an asynchronous this way. So we already did something like this, but they tested with the WebSocket, we tested with HTTP. Now, every event that you send using the send function or receive is a Python dictionary. Basically, when Uvicorn receives requests, it will send them to your application as Python dictionaries. And when you tell Uvicorn to send a message back, it will send it back as a dictionary. And that's in good conscience too, because if you send it back as a dictionary, you can pass it as a JSON. Now they say event, I prefer the term message. It kind of resonates well with my mind, so I'll just use the term message, but I'll be implying to event. So you can see here they were awaiting an event to happen, or they were awaiting a message to be sent from somewhere. So if I come here and say message equals to await receive, then I print that particular message, you can see it started. Let's refresh it. Oh no, that's wrong part. Even refreshing this doesn't do anything because we are refreshing basically a indentation expected and indented block after a while statement on line 21. Oh, this is an error before when I hadn't put something in this while. So a message is sent. I want to print that message. Anyway, if the message has a type that is lifespan dot startup. We are asking if the message sent is lifespan dot startup. Now we can print the message. I think it's doing it as we did before was kind of ambiguous. That's why it did not work. So here we need a full colon. Oh, is it not reloading? Oh, I think something happened to my terminal, so I'll just take it off and start up another one. So because we're here, we need to go to venv, we need to go to bin, we need to activate, we need to clear that, and we can start our server again. Remember, when you type this, we are telling Uvicorn to go to the main file, find a particular function called app, and call it asynchronously, and it can reload if there are any kind of changes. Now we're getting errors because we checked with a single equal sign instead of two. And when we do, you can see we get two because it was sent here and it didn't come because our terminal kind of froze. I don't know why that happens in Z every now and then. Okay, so we got the lifespan startup message. In it, that's the way of Uvicorn telling us that the lifespan has started. It has sent to us that kind of message. We can send to it back. We can send back to it. Now, if we send this back to it, it's not necessarily sending back to the client. We're just telling Uvicorn, not the client. We're telling it our type is going to be lifespan dot startup dot complete. We are sending it another kind of signal if that happens, or if the message, I can just copy paste this so we don't take a lot of time. If the message sent is shut down, we can print the message sent, and we can also tell Uvicorn, fine, say thanks for telling us you're shutting down. We are also shutting down. We have already done the necessary things to do if our server is supposed to be shutting down. So shut down complete. So I think it froze again. I know it if I try and Control C and it fails to do so, I know that it just froze. Let's spawn up one again. And Python, not Python basically, we're going to say source venv bin activate, clear our terminal, then Uvicorn, we're telling it to go to the file called main. There is a function called app, call it and reload whenever we make any changes. Now you can see it sent a lifespan startup. Now I'm sending a Control C command to tell it to shut down, and this happened. So we can you can see the lifespan shutdown was sent, or you can just print it over here as an info. Info, we receive lifespan startup signal Uvicorn, then I can copy this and just paste it here, and we receive shutdown. We receive shutdown signal from Uvicorn and start up the server again. Now we receive a lifespan startup from signal from Uvicorn, and you can see the particular message that was sent is that, hey, the server is starting up, so if there is anything you're doing or you want to do while the server is starting up, it would be nice to do it right now. Now, you may be asking, what are those type of things? So, for example, in FastAPI, maybe if you are using FastAPI to deploy a machine learning model or a deep learning model, maybe a computer vision deep learning model, those models can be huge sometimes depending on the type of architecture used. Okay, so let's say it's a ResNet 50 and you're starting up in a VPS of not so much compute. You want to start it up early. You don't want to start it up whenever the requests are coming. So you might want to have you might need the control to start it when the lifespan of the particular server is starting. So if you are working with FastAPI, you might have written something like app on event startup. That's what that can match something like this. But this is more under the hood. So in FastAPI, I don't have to write something like this manually. So that's it. Now let's bring back our HTTP codes so that we can wrap up and understand the flow even better. I'll just say if the particular scope has a type which is HTTP, I'll just highlight all these codes and send them to that particular scope. Oh, should have uncommented them so I wouldn't have to highlight twice. There we go. Now our server can handle two types of things, okay, but at different times. What do I mean by this? Our server is on. Let's track the flow. Let's track the flow of whatever is going on here. So when the server starts, Uvicorn sends us a signal that, hey, your server is starting. We receive the signal right here, and our server starts. Okay. So basically, this if message is executed, and we also send it back the just acknowledgement. Hey, thanks for telling us, and we've also completed our startup. So we send it back a signal so that it can break out of this kind of loop. This won't happen because we haven't sent a shutdown signal yet. That means this call, because it's in a while loop, it will go back to while true, and it will come back here. It will wait for another event. Remember, we're still in lifespan. It will wait for another event. It will wait for another message. But the other message it's waiting for is the shutdown message. Now, if this was not a synchronous function, and if we didn't send these as asynchronous, that means we would be stuck. But because we are waiting for something that we do not know when it will happen, by the way, when this happens, we need to return. So the whole function just goes off. So when this happens, that we are back here waiting for this, we can pause and allow the call function to be called again, which it will be called again when we make a HTTP request like this one. Now this call came again to this function. Came to this this instance of our MiniAPI class, and when it came to this instance, it called this particular function async call over here. And when it called this function, it checked again, is it a lifespan? So we know if we need to shut down. No, it's not a lifespan. This time around it's an HTTP. So now it goes back here. So there is this call, this previous call still exists, but it's paused. Okay, it's paused. It's paused, waiting for the shutdown message to be received so that it can terminate. But we don't want, while receiving it, to stop anything else from going on. So because the function itself is asynchronous, and these messages were called with await. This is the main keyword, await. And also the reception is using await. We're simply telling it, if you're not receiving it right now, if there is anything, no, this is not delayed because of IO. This is not delayed. Basically, it's delayed because of IO, because if I control C here, it's an IO. We are sending it's an input output. You are sending an input that the server should stop. So basically, it's waiting for that. But we don't want, if it's waiting, if it would wait without the await, that means it wouldn't pause. Okay, if it wouldn't pause, our server would be stuck in a lifespan without doing anything. We want it to start a lifespan, but also be able to do something else. You can think of it as opening. Let's say you open up a restaurant. If you go to open up in a particular workday, you want to open it and do other things. Then at the end you close it, right? So you get it to office, you open it. You don't want to open it, then you don't want to not receive any other tasks to do. So if you open it, you await the time to come when you will close it, but at the meantime, you do something else. The doing something else, that means is this await enables us to break out of this while loop, enables us to break out of this if statement by sending the whole call to the background. That means another call can be made to this call function, which is associated with an app instance, and whenever that call comes, it can be received and sent back to the if scope HTTP part of our application. So basically that's it. And